Welcome to Sabo. All right. Some will say the Sabo, but it's actually to Sabo. It just means help, please. All right. To Sabo, as in to Sabo Crypto, is just a platform that will educate people about crypto. Okay, it's an educational platform that will just educate people about crypto. It will talk about what's happening in the crypto environment. What are the latest news about crypto? What's the latest cryptocurrencies? What should you look out for? What should you buy? What should you be interested in? Okay, all things crypto. All right, Tusabo will be talking about all things crypto. So if you are interested in crypto and you want to know more about crypto and why is everybody talking about crypto? Where is crypto going? Where and why are people are so interested in it, and why are people making money from it, and and why is government having issues with cryptocurrency? All right, this is a place to be. Okay, crypto is definitely technology, and as we know, technology is taking over. Okay, and technology is hard to regulate. So that's why governments are, that's why there's a lot of tension between politicians and and the crypto community, and governments and the crypto community, and traditional investors, that invest in the dollar, the fiat systems, the dollar, the euro, and all of that. Why there's a lot of tension. Okay, so to Sabo Crypto, we'll be looking at all those things. Okay, so if you want to know more about crypto, if you're just getting started with crypto, and you want to find a place, where you can go to just to get your questions answered, to Sabo Crypto is the place. Okay, so this video, okay, is part of a series called What Is series. Okay, What Is series is just going to be talking about what is series is just going to be talking about um what is what is blockchain, what is Bitcoin, what is Ethereum, what are NFTs and stuff like that. Okay, so it's gonna be asking questions. It's gonna be answering questions about. It's gonna be answering questions that people are asking about, basically. Okay, that's the reason why I wanted to start with the What Is series, because it's going to address a lot of questions that people have when it comes to crypto. Okay, so this video is one of a series of videos, and it's all about blockchain. Okay, this video is going to be talking about what is blockchain, right? What is blockchain, and why is it so powerful? Okay, and why is the next best thing? All right. So what is blockchain? Let's get started. What is blockchain? Okay, in order for you to fully understand what cryptocurrency is in general and where it is going, you need to have a good understanding of what is blockchain and why is the world moving towards this phenomenon. All right, is this the new money? Is it a bubble waiting to burst, or is it just a technology fad? All right, a trend that will come and go. All right. Um, Personally, I don't think I think blockchain is technology, and technology is replacing jobs. Technology is taking over manual jobs. Okay. And I think blockchain is going to be at the center of it all. All right. Yes, blockchain is new. All right. That's why there's a lot of tension, but it's definitely going to be at the center of technology. All right. Let's move on. What is the difference between blockchain and cryptocurrency? All right. Let us find the distinction of cryptocurrency and blockchain. Okay. A good analogy is a casino. When you take your fiat money, your fiat currency like your dollar or your euro or whatever, and exchange it for chips. Those chips that you use in the casino, that is the cryptocurrency. The casino, as in the whole casino, that is the blockchain. So the chips only work in the ecosystem that is in the casino, but outside the casino, the chips have no purchasing power. So, so that's what it is. There is the distinction. So, blockchain is a distributed ledger, all right? A ledger records transactions, okay? So, a ledger records transactions, and those transactions are just distributed across the network. So blockchain is a distributed ledger that records transactions which are validated by consensus. All right, those transactions that are added onto the blockchain, all right, are validated firstly by consensus algorithms. All right, so that the transactions are valid and they are fair. Okay, so the money or the medium of exchange in the blockchain is the cryptocurrency. Okay, like the chips in the casino. All right, so you have to understand what is the difference, what is the distinction between blockchain and cryptocurrency. Cryptocurrency is a medium of exchange. It's like the money, right? That's the cryptocurrency. It's the money in the blockchain, and then it's like the chips in the casino, and the blockchain is like the casino, right? Okay, so there is the difference. Let's move on to the next slide. Now, let's talk about distributed ledger. All right, you need to understand what a distributed ledger is in order for you to understand the core of blockchain. All right, because the strength, the core strength of blockchain is the distributed ledger. All right, let me explain to you. Blockchain is basically a distributed digital ledger that records transactions, and that ledger is distributed across the entire network. All right. A blockchain is like a chain of blocks that are joined together by cryptographic algorithms that make it very difficult or nearly impossible to change or cheat. All right. The reason why it is so difficult to change or cheat is because the ledger is not held by one node. All nodes on the network hold the ledger, and the ledger is distributed across the chain, which means that you would have to change each and every ledger in order to change or cheat the system. All right. Blockchain was derived from the idea of timestamps to know what data existed at what time so that you cannot go back and change it or delete it. Okay. This means security and decentralization. All right, meaning no one entity or organization can come and mutate things to their benefit because every participant in the network has access to the information and may have a say. All right, so a ledger. A ledger is something that records transactions. Transactions could be anything, all right? It could be me sending money from one person to another. It could be me saying that I've got $1,000, okay, or €1,000, all right. That is a transaction, all right. It's a balance, all right. It says that I've got a balance of however, all right, or whoever has a balance of whatever, all right. All of those things are transactions, okay. Okay, every single thing that we do is a transaction, all right. Because a transaction could be anything and it just holds information. A transaction could be anything. So a distributed ledger holds transactions, right? Whether it's balance, whether it's sending money from one place to another, whether it's any single information, all right, is a transaction, all right. And a blockchain holds those transactions, but before it stores those transactions into the block, it first has algorithms, okay, consensus algorithms that validate those transactions, okay, and validate those transactions, and then once those transactions are validated, those transactions get stored, get minted to the block. All right, we'll talk about consensus algorithms a bit later. Um, um, but all you have to take away from this slide is that a blockchain, the core of a blockchain, is a distributed ledger. Everyone on the network has access to that ledger, not one person, like the way traditional banks work, like the way traditional companies work. Okay, traditional companies are centralized because they do what they want to do to benefit them, and we can't see what they're doing, or we have no say to what they are doing. Okay, that is a centralized system, like traditional banks, like normal traditional banks. That is a centralized system. They do what they want when they want. All right, and they can do it behind your back or in front of your face. Okay, but with blockchain, the power of blockchain is the fact that it's decentralized. Okay, everyone is the boss. All right, everyone has access to the ledger and holds transactions. All right, and those transactions are added in a consensus algorithm. Okay, so there's certain algorithms that are in play so that we make it fair for everyone. Okay, that is a distributed ledger. All right, we'll explain a bit more in the next slides. Okay, so the properties of a distributed ledger. All right, remember, what is a ledger? Ledger holds transactions. Now, programmable. Okay, the properties of a digital ledger technology, it's programmable. A lot of the blockchain being developed today is programmable, meaning that it's got code, which means that you can run smart contracts. It has code, which provide autonomous decision making. All right, there's no chance for human error because it's got code. Code has certain terms and conditions that need to be met. Once those terms and conditions are met, then the transaction can happen. Okay, it's programmable. It has no emotions. It's got no feelings. All right, it just has terms and conditions that have to be met, and then they give you a certain result. Plain and simple. It's secure. The blocks are joined by some sort of cryptographic algorithm. It makes it even more secure. Each record is individually encrypted. All right, anonymous. Blockchain offers participants some sort of anonymity or pseudonymity. Now, it's anonymous because the person, the way you don't need to know who's the person behind the transaction. All right, just as long as the person follows the rules, okay, the transaction will be valid. Okay, all right. It's none of my business who does what. It's none of my business who I buy whatever from, whichever coin from. All right, just as long as each and every participant follows the rules. It's that simple. That's simple. Follow the rules, okay? And the rules are built in the distributed ledger. They built in the consensus algorithm, and it makes it secure. So we don't need to know the party behind whatever transaction. All right. Only certain conditions have to be met. All right, and then that's it. Unanimous decisions. All nodes and participants on the network have to agree to the validity of each of the records. All right. So it's a decentralized system. There's no one party, there's no one entity that can make unfair decisions. Each and every participant on the network has to agree, and they have to find each record valid, right? That makes it fair for everyone. There's the power of blockchain technology. It's fair, it's open for everyone. All right, it doesn't matter who you are. Okay, it makes it fair. Okay, time stamped. A transaction is given a timestamp which is recorded on the block, thus allowing you to keep track of all the data and allows for transparency. All right, it's time stamped. Now you can't go back and change it. No, you can't. All right, it's there. It's time stamped. There is the power. There is the security. You can't go and modify it for your benefit. Okay, there's no malicious activities that can happen because it's there. It's time stamped. Okay, immutable. Any records that have been validated are basically irreversible and cannot be changed. Thus, keep track of all data and being transparent. All data is there. It cannot be taken back and changed. All right. That's where the power comes from. Because now, because it can't be changed, no one can go back and change it. Okay. And That's the reason why blockchain. That's the reason why blockchain is so powerful. That's the reason why anyone can join a blockchain community. And you just know that there are certain rules at play. Everybody has to follow the rules, otherwise the transactions won't be valid. All right. Um, Distributed, seeing that everyone on on the node has a copy of the ledger, and that each node has to be in consensus when adding a new block. This makes it very secure. All right, everyone on the node has a copy of the ledger, makes it very secure. All right, each node has to be in consensus when you're adding new transactions. All right, blocks transactions get added to a block, and then that block gets added to a chain of blocks. Okay, so information transactions get added to a block, that block gets added to a chain of other blocks. Okay, hence blockchain. All right. So it's distributed. Everybody has a copy. Nobody can cheat anyone. All right. Obviously, there are other ways they can take your money, but that's through like scams and when you're not careful or when you get hacked or whatever. But in terms of the way blockchain works, it's distributed. Okay, it's fair. All right. So this is a block. All right. Block has data. Okay, this is a block, just one block within blockchain. Block has data, you store the data, the transactions, and everything in the data block. The hash is, or it could be any cryptographic algorithm, any type of encryption that happens because the blocks are connected to each other by cryptographic algorithms. Okay, it just makes it secure, so you can't go back and change because when you change the information in the data, it automatically changes the encryption the encryption algorithm, and now it affects each and every block going backwards. Okay, so data is stored. All right, transactions are stored in the data. Cryptographic algorithms, blocks are joined together by cryptographic algorithms. All right, and the hash of the previous block. Okay, let us look at the next slide so you can understand. So the data is stored. Each block is connected via an algorithmic cryptographic algorithm. Okay, all right. So let me just read the slide and explain to you. Okay, blocks which are connected by cryptographic algorithms. Each block on the chain block joined to another block by a cryptographic algorithm contains a certain number of transactions, and every time a new transaction occurs on the block, the record of that transaction is added to the block, thus added to the ledger, and everyone on the network has access to it. Transactions are recorded with an immutable cryptographic signature, for example, a hash. Thus, when you try to change one block's data in a chain, it will immediately be apparent to everyone on the network that is that it had been tampered with. This type of system is called a distributed ledger technology. Blocks are joined by cryptographic algorithms. The below explains it in more detail. Okay, so each block on the chain is joined by a cryptographic algorithm. All right, let's see. Let's see here. So each block on the chain is connected by a cryptographic algorithm, right? And each block contains a certain number of transactions. And every time a new transaction occurs on the block, that every time a new transaction occurs on the blockchain, the record of that transaction is added to the block. So have a look on block one. Okay, the hash is 13DF. All right. All right, that's the cryptographic algorithm that is joined. Okay, the previous, okay, because block one is the genesis block, it doesn't have a previous block to it, so there's no previous hash. All right, because block one is the first block on the blockchain, it doesn't have a previous block to it. So because it doesn't have a previous block to it, it doesn't have a previous hash. Okay, so block one, the hash is 13.13 df. Okay, right? So it's connected to block two. Okay, and now it's connected to block two, which has a hash of 7dy1. So block two stores the previous hash of block one. All right, and because block two stores the previous hash of block one, now the previous hash is 13df. Okay, so if you were to change uh, uh, a block that's already been minted, block one has already been minted, this previous hash will have to change. And that's when you want to see that something has happened, something has been tampered with. So block two has a hash of 7dy1, all right? Okay, block three has a hash of 3b4c, all right? But what joins the hash that joins block three to block two, all right? It's 70y1. Can you see? All right. So these blocks are joined together by cryptographic algorithms. Okay. So if you want to change the data on block two, the hash changes automatically. All right. So block three is gonna realize that no, but your hash has changed, meaning that you have changed something in block two. Okay, that's where the security comes from. That's where it becomes very difficult for you to change anything that's already been connected, a block that's already been minted. Okay, all right, it's hard to change a block that's already been minted. Okay, so let's move on to the next slide. Now, first block and immutability. All right, the first block in the blockchain is known as the Genesis block, which is a special block because it doesn't have a previous cryptographic algorithm attached to it. Okay, the first block is a Genesis block. Why? Because it doesn't have a previous block to it. It's the first block. Now, this is how they are joined together. All right, blocks are designed to store information in a cryptographic way so that the integrity of the information is maintained and stored accurately. Each block is added to the next block, okay, by certain algorithmic processes like proof of work and proof of stake. Now, each block is added to the next block by using consensus algorithms like proof of work and proof of stake. As new confirmed transactions, as new confirmed transactions and information is being available to the network, information on those blocks that have been added are recorded on the ledger. Okay, information on those blocks that have been added are recorded on the ledger, and that ledger is distributed to all the nodes on the network. So when you change a block that has already been minted, added to the blockchain, this changes the cryptographic numbers that are used to attach the block. Thus, you can't see what the block has been changed or tampered with, what the block has been changed. Thus, you can see that the block has been changed or tampered with. Now, block 1 has a hash key of 13df. Block 2 has a hash key of 70y1. Block 3 has a hash key of 3b4c, but somebody comes and changes the block on block 2. Now the hash changes, and now block 3 can see that no, your previous hash was 70y1. Why has it changed? Okay, that's when you want to see that okay, something is up. Okay, so don't worry about the cryptographic algorithms, all right? That's not important. What you need to worry about is that the blocks are joined together by encryption, by cryptographic algorithms to secure the chains. and make sure that you can't just come and change things. Okay, and those transactions and those hash codes are recorded on the distributed ledger. Everyone has a copy of that ledger, so you can keep track of what's happening. Okay, now transactions are validated and added to the block through methods such as proof of work and proof of stake. Okay, now what is proof of work? What is proof of stake? Proof of work and proof of stake are both consensus mechanisms that validate new transactions and add those transactions on the ledger. They agree on the state of the network. Proof of work use computers to validate the transactions, and proof of stake is more of a deterministic way through using the owners of the coins, the cryptocurrency, that allow you to validate transactions. Okay, so proof of work, they make use of computers to validate transactions. Proof of stake is more of a deterministic way. Way through which owners of the coins, all right, the owners of the coin are allowed to validate the transactions. Okay, so proof of work is more expensive and wasteful because you are not guaranteed a reward for your efforts, because everyone is in a race. Everyone is in a race to solve a puzzle. And now, if somebody gets there and solves the puzzle before you, that person gets the reward. So it can be wasteful because computers take power, right? But it tends to use a lot of electricity and power. Yeah. So proof of work has miners and proof of stake uses validators. Validators are chosen at random, and those who have more coins have a higher chance of being chosen. Okay. All right. So validators are chosen at random. There's a random code that's written. All right. And those who have more coins have a higher chance of being chosen, which makes it fair because you have more coins. Okay. But and it's random, which also takes away the fact that because the person has more coins will always win. No, it's also random, but it also increases the chances of being chosen if you got more coins. All right. So transactions are validated and added to the block through methods such as proof of work and proof of stake. All right. Um, uh, Transactions on the block is approved by miners. Okay. Transactions on the blockchains are approved by miners. Sorry. Um, in a proof of work or proof of stake system, when you in a proof of work or proof of stake system, when you perform a transaction, the transaction is passed through a pool and will remain unconfirmed until miners approve and confirm the transactions. Okay, so miners are the people that validate new transactions and record them on the blockchain. This comes with transaction fees, which is paid to the miners for their efforts. Miners validate new transactions and mint the new block of those confirmed transactions, recording each transaction on the distributed ledger. Adding a block involves some mathematical or cryptographic problem which needs to be solved before the block is added. There is obviously more information regarding mining and proof of work, which I'll make another video on later. Okay, so all you have to understand is that transactions on the blockchain is approved by miners in a proof of work or proof of stake system. Okay, it doesn't matter. When you perform a transaction, that transaction has to be passed through a pool and will remain unconfirmed until miners come and approve it. Okay, miners are the people that validate new transactions and record them on the blockchain. So this comes with transaction fees, which is paid to the miners for their efforts, and some have block fees. All right, which are also paid to the miners. Okay, so yeah. The security of the blockchain. Now, as mentioned above, if you tamper with the hash or the cryptographic algorithm, it automatically affects the cryptographic keys of other blocks. Okay, so But seeing that computers are extremely fast, they can calculate the hash key in such a way that it doesn't affect the blocks in front of it. That is why there are mechanisms like proof of work and proof of stake that validates the security more, because there is a certain amount of time that needs to be elapsed before a new block is added. Because computers are fast and they can quickly tamper with the hash code. There's time that needs to be elapsed before a new block is added. So that makes it difficult for a computer to actually quickly come and change the hash key, thus adding more security to it. So when you add a new block, you need to validate it against other nodes of the network. Then once there is consensus, then that block can be added to the blockchain. Now, they secure themselves through peer-to-peer network instead of a centralized network. That way, consensus will further secure the blockchain, and all these facts remove trust and prevent malicious activity. There's no trust in a blockchain. We don't need trust. Okay, just as long as you follow the rules and you meet the terms and conditions, that's all we care about. We don't care about your trust. Okay, why is blockchain the future and what is its use case? All right. Blockchain is technology and technology is the future. What is the use of blockchain and how can it solve traditional problems? As more and more people get access to technological devices, they are going to look for a more fair and open system where they can do their banking, entertainment, and everything that traditional technological systems offered. Okay, so blockchain can solve many problems that exist in the traditional way. The use cases of blockchain are limitless and can span in many different industries. Okay, the use case of blockchain are limitless and can span in many different industries. Here we just mention a few. Okay, um, financial use through means of providing financial services that traditional banking systems provide, like lending, borrowing, saving, paying, etc. All right. Blockchain can facilitate trustless payments in a decentralized way and a very cost effective way. It also provides you with an opportunity to be your own bank. All right, because we don't need trust, because you just need to meet certain criteria. All right, we don't need trust because you just need to meet certain criteria. Okay, that's what makes blockchain so powerful. It's decentralized. All right, nobody can come and bully somebody else. You just need to meet the criteria, need to meet the terms and conditions, and then that's it. You can be your own boss. All right, nobody can come and cheat you. All right, you don't need trust. You can pay one person and you can transfer money from one place to another in a quick, fast way. All right, you don't have to wait for the bank to verify this, verify that, and then only send it after 2 days or whatever. No, it's now, it's instant. All right, at a click of a button. Okay, with no transaction fees. Okay, that's the power of blockchain. All right. Okay, and blockchain is so fair because it makes use of the current exchange rates. All right, whereas a bank changes the rates. Let's say the euro to the dollar is 150, but they only want to give you 130. All right, all right. With blockchain, there's none of that. Okay, so cryptocurrencies, seeing that time stamping is integrated in the blockchain, it allows you to verify proof of existence when a transaction was created and what it contained. Okay, so you know the person has money, therefore that money can be transferred from one place to another, and there's a record of that. Okay, and it hasn't been tampered with. Right, this timestamp opportunity opens an opportunity for various types of currencies that can be moved around in various ways beyond the traditional finance way. You don't have to sign up, documentation, a lot of red tape. None of that. None of that. All right. Cross border payments. Blockchain provides fast cross border payments that are faster than traditional payments. payment systems that exist. All right. Plus, they can provide payments at a cheaper price. It's autonomous. It's just code. All right. You don't care about humans. You don't care about human error. All right. It's fast. It's quick. It's cheap. No questions asked. Okay, blockchain can contribute hugely on insurance industry due to the transparency and security due to immutable records. Right, blockchain can contribute hugely when it comes to the insurance industry. All right, the insurance industry is in a mess. It's in a big mess. They do as they please. Okay. We're not gonna get into that there, but just know blockchain can do insurance and can be transparent. Okay, goods, products, and services, whether we consume them or not, we need to be they need to be tracked. Okay, need to be tracked, be it physical or digitally. All right, these allow us to authenticate and track flow. And check flow that goes in and out, to authenticate and check the flow that goes in and out. Okay, blockchain can definitely assist in checking in checking goods that are being distributed and verify if something is authentic. Okay, yeah, so you can just blockchain can verify if something is authentic because you know where it's from, you know when it was created. All right. Okay, there's a address attached to it, so you know if it's authentic. Okay, voting on the blockchain can contribute immensely when it comes to voting, allowing us to get rid of fraudsters and check the number of eligible voters, plus have a secure record of each vote that occurred in the past. Therefore, everything is audited and checked holistically without manual labor that can have human error or human interference. Identity and knowing your customer. A lot of documentation, such as birth certificates, ID documents, and many other forms of identification, get lost forever. The best system to combat such is have a blockchain solution that stores documentation by digitizing and converting it into online formats that is immutable. Blockchain can store KYC information, know your customer, in a safe and secure way that can be utilized by other parties to verify their customers. It will always be there. It will always be immutable. Okay? It will always be there for reference. You can't come and change it. Okay? So, conclusion. So we need to take away from this. So what we need to take away from this is that blockchain is a distributed ledger that allows anyone to join the network and adds information to the block through certain conditions and use cryptographic algorithms to secure the process of the data and transactions. Okay, because the ledger is distributed, it doesn't allow for changes or makes it nearly impossible to change already previously minted blocks. It allows data to be recorded in a transparent and fair way. Due to smart contracts, it also provides autonomous transaction and very cheap transaction fees. Because the ledger is distributed across the entire blockchain, no one entity has control or can own or can own make decisions to benefit them solely. All right, it is decentralized, open, fair, and in many cases a cheaper alternative that the traditional ways of doing things. Okay, so it's a cheaper alternative than the traditional ways of doing things. Blockchain has many uses, and it is only the beginning.